In this session, we'll start first by uh, going over energy trends and the great transition in use of energy. And then we'll start to talk specifically about energy in building. So hopefully next time we'll start then to introduce computational fluid dynamics software, how we can simulate energy in buildings. So to start with, as you all know, energy can be in several forms, and we can transform it from one form to the other, depending on if you want our purpose. And sometimes the same cycle, you can use it in different ways. Sometimes you can put electrical power, let's say, to produce heating or cooling. So you go from energy in form of electricity to energy in form of heat. In other cases, you put work, let's say, in order, or you put energy in form of heat, you use combustion or use any other process in order to produce electricity through the turbine, which will run the generator. So for the same cycle can be used in several ways depending on your final purpose, final goal. Now, when we talk about energy, we should be familiar with the energy chain. We know that energy can be in several forms. When we talk about primary energy, it is, as the name indicates, it's the primary state of energy without modification. So it is the energy that is embedded in resources as they exist in nature without modification. So they haven't been transformed or converted. We can talk about several examples of primary energy, including, let's say, chemical energy embodied in fossil fuels or biomass, the potential energy of water drawn from a reservoir. You know that, for example, dams are constructed based on storing energy in form of potential energy first. And then when we open, let's say, for water to move, when we open the gate, the potential energy will be transformed in kinetic energy. And this kinetic energy will after lead to rotation of the turbine blades to produce electricity. The second mode of energy is secondary energy. So it means that energy that has been converted from primary form to another forms that can be now after used. So for example, when we talk about secondary energy, electricity or heat is the example. So when we take the example of the dam, the potential energy is the primary form, the potential energy in water. The secondary energy is the electricity that will be produced after conversion of this potential energy. In other applications, for example, you can use, let's say, chemical energy in fossil fuels will be used to produce heat. So when you do the combustion, the secondary form of the energy will be heat. Now, concerning the final energy, when we talk about final energy, it includes energy made available to the consumer before its final conversion. So before using it, we can talk then about, for example, a grid delivered gas or electricity at the point of a wall socket. So just before we use it in home, for example, if you have electricity available, when you press the button on, then you will have it in the final form, which is the useful energy. So the useful energy will include energy that is available to the consumer after its final conversion. For example, we can talk about lighting, about refrigeration, heating and cooling, etc. Please stop me if anything is not clear. Now, the final form is the energy service. And when we talk about energy service, it's not if you want energy career, but it's a kind of energy that is delivered to people. So, for example, heat radiated from a residential heat source, or if we talk, let's say, in transportation, the kilometers traveled by the passenger car is the final energy service. Now, of course, we know that the amount of primary energy is increasing with time, and with technological advancement and with the development of industry, we are in more need to use of primary energy. And primary energy can be present in several forms, including renewables, hydroelectricity, nuclear energy, coal, natural gas, oil. We know that recently we are more and trying to rely more on renewable energy. So if we observe, if you want, in last years, we can see the increase of rate of use of renewable energy. And the concerning fossil fuels, we are trying to reduce the rate of increase of oil and fossil fuels. So we can see that mainly the big development is in the renewable energy field, because we are trying to rely more on solar, on wind energy, etc. For hydroelectricity, it has been used from long time ago. So if you can see here, it's already used, and we are using it, but we always have an increasing trend. For all types, you can observe an increasing trend. Okay, but the percentage of, for example, renewable energy is increasing relative to the total energy. So here we can see it better in this graph. We can see the shares of global primary energy function of time. So we can see the advancement and share of renewable energy. So if we look at the graph here, you can see, for example, the decrease in sharing of oil recently, and also the decrease in sharing coal, while mainly renewable energy has an increasing trend. So the future, as we know, is for renewable energy. That's why we are trying to develop technologies related to renewable energy to be able at the end to replace all non-renewable resources. So if we look at the following graph, we can see how the primary energy consumption for fuel is varying, the percentage, how it is varying. If we look at the graph, we can see, for example, that for oil, we are trying to rely less on oil. So as you can see, we start to observe a decreasing trend, while for other resources, especially renewable energy, we start to observe an increase in trend, because the percentage was relatively small, let's say, and it is increasing. Plus, if we look at different regions, okay, so if you explore in different regions, we can see mainly that in a lot of regions, we are starting to use a big percentage of renewable energy. Let's say specifically in, for example, in Europe, you have one of the highest percentage of use of renewable energy. Same in North America. So in general, developed countries are the first countries to start to use renewable energy in a high percentage. And this trend is also is starting to be observed also in developed countries. So we already know that petroleum reserves are decreasing with time, and but we are still trying to explore for new reserves, okay, for reserves of petroleum, for reserves of gas, etc. And we can categorize these reserves into several categories. To start with, when we talk about proven reserves, these reserves are actually found by drilling operation and are recoverable from known accumulations by means of current technology. On the other hand, sometimes we have probable reserves. And if we take the example of gas in Lebanon, okay, in recent years, we considered that we might have reserves of gas. So these are probable reserves. When you do the drilling operations and you make sure that you have a certain reserve of gas or reserve of fossil fuels, then you can consider that they are proven. So probable reserves are reserves that are nearly certain, but about which we still have a slight doubt. Possible reserves are reserves with an even greater degree of uncertainty about recovery, but which there is some information. So, in general, whenever we start, we can say such zones probably will contain, let's say, gas or fossil fuels, and we do this from geological analysis. But once we do the drilling process, we can be sure if we have them. And then the challenge also is to determine the quantities. So if it's worth to invest in this or not. Like, for example, in Lebanon, you know that, let's say, Total is trying to see if the quantity is enough to invest. Yeah, it's if it's worth economically to invest or not in Lebanon. Concerning potential reserves, they are based on geological information, and they are considered to represent just an educated guess. And of course, you have some experts in this field that can, let's say, determine certain regions that have high probability of containing reserves. And we have the undiscovered reserves, which constitute little more than figments of the imagination and should be used with extreme caution, because we don't have a lot of data that can certify or that can tell us that we have high probability of finding reserves in these places. Now, a very important ratio that we calculate whenever we study reserves is reserves to production ratio. Because you know that always we try to have some excess to not reach a time where we have, let's say, a shortage, let's say in oil and fossil fuels, etc. And for example, you know, let's say when we have the war of between Ukraine and Russia, this resulted in a high problem in oil, if you want, share between different countries because of politics. So that's why, in general, a lot of countries try to have a large ratio of reserves to production. So if the reserves remaining at the end of any year are divided by the production in that year, the result is the length of time that those remaining reserves would last if projection would continue at that rate. And for example, let us say we have reserves, let's say, of 1,000 tons of a certain quantity, okay? And we are using per year 500 tons, okay? So a simple calculation can tell us that the ratio of reserves to production is 2. So we still can have 2 years without shortage, okay? So we try always to increase this ratio to be on the safe side. So each year there are declines in reserves in some countries and increases in the other. Of course, we are doing the assumption, if you want, of constant production, which is not always the case, okay? But as a acceptable assumption, we can do this to get a certain estimate of the number of years that we still have to use these resources. So here we can see oil reserves to production rate in several countries. Of course, when you have a country that is recently, if you discover recently reserves, this will lead to a sudden increase in the ratio of R over P. Okay, so as you can see here, for example, let's say in South and Central America, we know that now these countries are very rich in such oil reserves, and they are extracting oil. This lead to a sudden increase in the ratio of reserves over production. So mainly currently, these countries represent one of the main sources of oil. While, let's say, for example, if we take the example of the Middle East, because long time ago we discovered these resources, we are exploring a decreased trend in Middle East. And that's why in Middle East, we are starting to go to different strategies, because with time we have decrease of this ratio and we might reach shortage in a while. And even despite this large increase in ratio of R over P for South of America, you know that these countries are under political constraints. That's why on the economical level, they are not very, if you want, the income of people and the level of money, the state of currency is not very good in these countries because you have political constraints on them. They cannot export, even if they have these reserves, they cannot export and they cannot gain enough money to enhance the economy of their country. So always the political issue will play a very important role in the economical development of a country. Even if you have a lot of resources and you have a very rich, let's say, land, then you can have, because of political constraints, because of, if you want, they put some restrictions on exportation, they put, let's say, a lot of conditions on you. So this will lead to a reduction of the economical development. So now we can see here, for example, how the oil consumption per capita is varying in different countries. And always, as expected, developed countries in general will have high consumption. This is the case of the North of America. Also, in addition, you have the countries that have high reserves also will be countries having high consumption because they have the resources available locally. Okay, so we can see here mainly that North America and the Middle East are the regions that consume oil in the greatest quantities. Now, if we observe natural gas, we can see also the Middle East is one of the zone where you have a lot of resources. You have natural gas, you have oil, but as we mentioned, we already discovered this, let's say, from 90s, and that's why if we are exploring the trend, we have a decrease in the ratio of reserves to production, because the production is increasing and the reserves are reduced with time, and we are very close to a shortage. So as we mentioned before, that's why we are trying to come up with new resources that rely on renewable energy rather than non-renewable one. So here also we can see the, if you want, the distribution of gas consumption in the world. And as usual, because you know that North America is one of the most developed countries, so you can see in all cases for different resources, it is one of the it is characterized by larger consumption per capita. For gas, Russia also, you know that Russia has a lot of reserves in gas, so this explains why we have a high consumption in Russia. In the following graph, we can observe liquefied natural gas imports by source. You know that gas, before the invention of liquefying natural gas, it was a resource that we cannot benefit a lot from. We can just benefit from it locally, but with and even locally, and whenever you if you want to take it from the source, if you cannot store it in a good way, you cannot use it. And gas is very difficult to store. Plus, you need large volumes to be able to store it. That's why a very important technology was liquefying natural gas. This allowed first to store in smaller volumes, much larger quantities. Plus, this helped into exporting natural gas from one country to the other. And you know that we have now, let's say, a big map in the world for exportation and importation of liquefied natural gas. And when we talked about the electricity problems in Lebanon, one of the solutions was to import liquefied natural gas from Egypt. Okay, so it is a resource that we are relying on to produce electricity and to produce energy. Of course, as usual, in some countries you can observe some peaks for certain times and then reduction. So this is affected by several cases. Whenever we talk about importation, it's mainly affected by political issues. So we can see that in Europe, the maximum consumption was around 2010. And then we started to have a decrease in consumption because we were trying to rely less on importation and rely more on renewable energy. We can see also that in several countries we have like nearly steady state importation. While here we can see some increase in of importation, let's say from countries other than Australia, Qatar, Indonesia, Russia, and Malaysia. So we can see here one very important aspect when we do importation is to try to import from several sources, because you know that any political problem, any unexpected war can lead to reduction of importation. That's why if a country is importing from several sources, it is on the safer side, and it can avoid shortage of the resource of gas, for example, here. So let's say if you are only importing from Russia and you have the war, okay, this can lead to a large shortage because of problems in importation. While if you import from several countries, then even if you have some political problems in certain regions, you still can import from others. So also here we can explore the variation of coal consumption worldwide. Okay, so always here we can observe for different countries what is happening. So as we mentioned, it depending on the region. It depends on if you want what was the time of discovery of reserves. This will affect a lot the trend. So for example, here we can observe that in North America, we have an increasing trend of coal reserve to production. This might be due to discovery of new reserves. Okay, while in other regions like Middle East, so nearly the Middle East region is having decreasing trends in the different non-renewable resources, and this is due to discovery of these resources from long times. Okay, so while in other countries you are still exploring new reserves, and with the advancement of technology, you have a lot of new technologies that can help you into discovering, if you want, reserves that are difficult to reach. We can discuss this if you want after, when we talk about fossil fuels. You know that the drilling techniques used at the first stage were relatively doesn't require a lot of development because the depth that you want to go through is not very large. But as you started to use reserves, you need to go deeper and deeper, and then you need more advanced technologies to discover new reserves. Now, concerning nuclear energy consumption is observing an increased trend until nearly, mainly you have until 2010, you have an increase and a very fast increase here along the 90s. Okay, but after the 90s we started to observe like a statu quo, if you want, with a small rate of increase, because of political issues mainly, and because of the safety issues, and we know that nuclear energy is really risky, and we are trying to avoid using nuclear energy by any country, and mainly developed countries are trying to reduce the number of countries that possess nuclear energy for political reasons, because we know whenever you have nuclear energy you constitute a risk on others, and this will and if you want will help you to impose some conditions on others, so like what is happening between Iran and America. Now, we know that the use of energy will affect a lot the climate. And we already discussed this because you know that whenever you use coal or fossil fuels, whenever you have combustion, you have generation of greenhouse gases. And greenhouse gases will play a bad effect on the environment. Why? Because the atmosphere will trap gases like CO2, and this will lead to increase of proportion of heat reflected to the earth. And we know that in general, we receive radiation from the sun, and this radiation will be transmitted through the atmosphere. Okay, now this radiation, let's say, will reach the earth and will be reflected back. So in case we have a high percentage of CO2, this will lead to absorption of waves in a certain range, if you want, of wavelengths, and this will lead to if you want, emission back from the atmosphere to the earth. So if you emit a large quantity of heat back to the earth, this will lead to increase in the temperature of the earth, and this need to be avoided because in some regions we can start to observe this, and even in Lebanon, which was characterized by a very nice climate, since you don't have large variation in temperature between winter and summer, you have 4 seasons, etc. You will not observe this anymore because you will have extremes and variation in temperature. You will have very large temperature, let's say, during summer. And if we continue under this trend, we can have really very large temperatures, and this will affect, you know, the economy of countries, because this will lead to reduction in productivity, to increase in consumption for cooling purposes, etc. So here we can observe some expectation for the climate change level in 2050. And we can see that we have an increase in temperature, which will reduce, if you want, the GDP in a lot of countries, especially in countries already characterized by high temperatures. And we know that, let's say, Africa, the Middle East, India, okay, or in this region, we have already high temperatures. And with the change of climate, we'll have larger and larger temperature, which will, as we discussed, will reduce the productivity, reduce the economical benefit, and increase the energy consumption. That's why we expect to have a reduction in GDP in such countries, while in other countries that are characterized by relatively cold temperatures, the climate change can have positive effects. Okay, but with time, if you continue with the same trend, will lead to overheating of the earth, and this will lead to very bad impacts. So that's why, because of all disadvantages that we discussed about greenhouse gases emission and global warming effect, we can see now that the future is for renewable energy, because the percentage of share of recent renewable energy technologies is increasing a lot. We are trying to rely more on renewable energy and less on fossil fuels. And of course, it's not very easy to get rid of the use of fossil fuels, because you know that a very high percentage of technology is already based on fossil fuels. So sometimes if you want to use renewable energy, sometimes you should invest from zero, or you should do large modification for your industry to be able to use renewable energy. That's why always when you begin by a new technology, the increase first will not be in a very high percentage, but as you start, you can go to, if you want, a very high rate whenever you start to establish regulations that will force to use renewable energy, especially when you construct from zero. And we know already that we have already available industries, maybe they cannot stop, they cannot change completely their way of functioning, and they will still rely on fossil fuels. They can try to implement in certain ways, and sometimes you can couple the use of fossil fuels with the use of renewable energy. So in this way, you can reduce the use of fossil fuels. And in other cases, especially let's say when we are building a system from zero, then it's better to make it, if possible, 100% relying on renewable energy. And if not possible to use 100% renewable energy, we can couple it with other resources as backup, but renewable energy should be the main source of energy in order to be able to overcome the limitations of greenhouse gas emissions and global warming effect. So we can observe, for example, that from 2009 to 2020, we were able to have an increase in percentage of energy from 8.7% to 12.6%. It's acceptable, but still we are waiting to have larger and larger increase. Now for fossil fuels, it's nearly stable with a small decrease. So what we are trying to do is to do, if you want, more research to come up with more technologies in order to be able to replace fossil fuels at a faster rate. So we know that because of the COVID-19, already the energy consumption was already reduced, okay, because of lockdown. But in general, we expect that in normal conditions, we'll always have an increase in energy consumption with years. So now, and you know that during the lockdown, one of the main advantages was the effect on environment. So a lot of scientists studying climate change and the effect on the environment have noticed a very good, if you want, increase in reduction in CO2 emissions, and this led to enhancement of the quality of air that we are breathing, etc. So the lockdown was of high benefit on the environmental level. Now, if we can look here at the share of net annual additions in power generating capacity using renewable energy resources, we can observe that we have an increase in renewable share compared to a decrease in non-renewable share. And this behavior is good, and we hope that it will continue at a faster rate until being able to rely, if possible, with a much larger percentage on renewable energy. So as we said, this trend is encouraging because we are observing that we are relying more and more on renewable energy, and we should keep on with this trend and try to enhance it, increase the rate of increase of use of renewable energy in order to hopefully replace completely fossil fuel resources. So we can see until now that nearly in 156 countries, we have power regulations, incentives to use renewable energy. And as we discussed before, in some countries, they force people to use renewable energy because they know that and at the end, even if now it is causing a higher cost of electricity, in the future we will benefit a lot from using it, because we'll get rid of not only the bad effects, the bad environmental effect of fossil fuels, plus we have always the risk of depletion of resources of fossil fuels. Also, with advancement of technology, we'll be able to reduce a lot the price of electricity by relying on renewable energy. On the other hand, also 70 countries impose the transport regulation and the incentives to use renewable energy. We know that now China is one of the main countries of production of electrical cars, and this domain is really expanding and progressing in a very fast way, and we are starting to observe